Hey everyone, I'm Sanket Singh. I'm working as a software engineer at Google and welcome back to my channel. So guys, in this video, I'm going to talk about my experience that I've been working with a lot of companies since like past 2.5 years. So according to my experience, how important are data structures and algorithms for your software development engineering journey, right? So this is a question that a lot of students ask, not in their initial stages of their learning, but like after spending some time with data structures and algorithms. A lot of students actually ask that, are they even going to use all of these knowledge somewhere during their work, right? So we are going to talk about that. I will be sharing you some very, I would say, key experiences, some key instances where I encountered a lot of things where due to which I was able to make a judgment on whether you should focus a lot on data structures and algorithm in your initial stage, or even when, let's say, you have already joined some internship or some full-time engineering job. Do you still need to have that much knowledge around data structures and algorithms so that you can excel in your software engineering journey? So this is going to be the topic for the video, and if you find the video useful enough, then don't forget to hit the like button and don't forget to hit the subscribe button so that you never miss a video whenever we are going to put a new video on the channel. So I would highly recommend you guys to watch the video till the very last, and without any further delay, let's just start. So guys, long story short, yes, DSA is important. Not at one point of time, but at multiple spots, I have faced some things that later made me realize that DSA was a good investment for me, right? Spending my time in DSA was a good investment for me. In a nutshell, if I would say that how much DSA is used in software engineering, then I would say the data structures part is used a bit more than the algorithmic part, at least according to my experience since I've joined all of these companies, right? So why data structures part is more important? Because a lot of time when you are working as a backend engineer, I'm going to suppose a few things around backend engineering. So let's say when you are working as a backend engineer, then a lot of time you have to consume a lot of APIs, you have to call a lot of APIs, you have to build models, controllers, right? You have to interact with the database. A lot of time you are interacting with a lot of data, and you have to process that data, you have to extract out meaningful information from that data. So a lot of time it becomes really very important to store that data in a optimized fashion, right? So when I was working at LinkedIn, I was working with Java based backend, right? And to be very honest, my knowledge around data structures, like when to use hash tables, sets, immutable sets, array list, all of these kind of data structures were like used on daily purpose, right? Not even like in a week or in a month. On daily purpose, I was interacting with these data structures like hash maps, sets, right, queues, and array list. All of these data structures were very regularly used, because whenever we are like consuming API, whatever language that you are using, in every language there are some implementation of these data structure, and it becomes really important to actually understand based on your use case which data structure you need to use. For example, let's say if you are having some static string values that you're not going to change, then instead of storing them in an array list, it makes more sense to store them in an immutable set, kind of like that, right? So having this much knowledge was very helpful for me, because like you will write your code and the code will go for review, then the reviewer is going to like put a lot of comments on your code that, okay, how about using this as a data structure, how about using that as a data structure. This is something that I realized that, okay, at least the knowledge of data structure is something that is going to be used on day-to-day purpose. And definitely core language basics are really very important apart from the data structures knowledge.
So I just told you all the places I've been using data structures and algorithms in my software engineering journey. But do you want to ace your skills in data structures and algorithms? Do you want to practice problems which are the most relevant to acquire DSA knowledge and learn from a structured and optimized learning path? Then do check out Unacademy, which is India's largest online learning platform, and they are providing a comprehensive DSA course led by none other than Love Babbar, who is a software engineer at Microsoft and a former SD1 at Amazon. The course is going to start from 12th of April 2022, which is 5 days from now. The price of the course is just rupees 4,000, and you can use my referral code STS10 to get amazing discounts on the 4,000 rupees subscription. you can use the link in the description section below to register on Unacademy from your mobile number and apply the code so that you can get amazing discounts on the course subscription. The course is going to consist of 60 plus live classes with topics like recursion, backtracking, stack, queue, graphs, dynamic programming, and many more. There will be a lot of questions going to be covered in the course, and the whole course is going to be in English. Apart from the topics, you are also going to get additional topics like concepts of C++, object-oriented programming, linked list, searching, sorting, arrays, etc. The whole Unacademy platform is going to provide you live interactive interface with study planner features, study groups, as well as raise a hand feature in the live classes. So, what are you waiting for? Use my code STS10 to register for the comprehensive data structures and algorithm course. Start the course for your understanding in data structures and algorithm, and let's crack it with Unacademy.
Now talking about where I used algorithmic knowledge, then I'm going to highlight few of the core instances where I actually used my algorithmic knowledge in order to solve some problems which based on some features that I was implementing. So let's just move forward and see what were those instances where I actually encountered algorithms. So during my tenure at Interview Bit, where I was working initially as an intern, then as a full-time engineer, there was a problem where we had to go for string matching kind of SQL queries. So you already might be aware, or if you are not, then you can read about it somewhere, that in SQL you can do string matching, right? You can do the pattern matching queries using the like operator, right? Now for our use case, the string matching was quite heavy, and we were not able to figure out that whether just going for a prefix match will be helpful for us, because we will be spending some manual time extra. But if we are going to go for a string matching kind of an approach, then the query in itself will give us all the data. It's just that we were not able to find the trade-off between whether the prefix match is going to be more efficient or the string matching is going to be more efficient. So at that point of time, we digged into more around the documentation of MySQL, that how exactly does the prefix matching, how exactly does the pattern matching for the whole substring matching kind of a thing. And then we realized that it internally used modified Boyer-Moore algorithm. So again, if I was someone who was not aware about string matching, like how KMP works, how Boyer-Moore works, how Z algorithm works, if I was not aware about these algorithms, then understanding in the first, I would say, instance about modified Boyer-Moore that SQL is actually using could have been a bit difficult, right? And I believe you guys also agree with that having some basic knowledge around some already written topics gives us a leverage that when we are going to read the advanced version of that topic, we are able to understand a lot of things. At that time, my knowledge of algorithms came very helpful. I was able to see the trade-off between how exactly the prefix matching is working, how exactly the string matching is working. Can we make some indexes for the SQL on the prefix matching? So these kind of stuff I was able to figure out. And this was the first time when I actually encountered real-life algorithms into my day-to-day job as a software engineer. So this was the first instance when I encountered algorithms. So the second instance when I encountered algorithms was during my tenure at LinkedIn. So again, I was interacting with the Oracle DB, and so what happens is I was working on a feature where I was using a lot of going with a lot of use cases, right? And in one of the use case, I had to return an error, right? So the SQL object from Oracle DB used to wrap a lot of, I would say, abstraction layer on the core, I would say, error layer object, right? So what my manager asked me to do was let's just not print that there was some internal server error kind of a normal log. For debugging purpose, we might need to actually understand what is going wrong with the code. So actually we need to find the exact error code that is thrown by the Oracle DB, not just the, I would say, 500 error that we are sending for the API. So then I realized that, okay, I need to see that how this object has been actually abstracted. And then I realized that Oracle DB offers a recursive way in order to actually fetch the internal error object, the core internal error object that we have to fetch. So at that time, I wrote a recursive algorithm to one by one peel off the abstraction layer of error objects, and actually went down at the lowest level and got the exact error, why this use case was throwing an error, and then generated logs based on that. So at this time, this was the first time, to be very honest, when I actually implemented a recursive algorithm in a production code. I never encountered a recursive algorithm in a production code that was written by me at least, or maybe my just like first connection fellow mates, right? So this was a recursive algorithm that I myself wrote, and I realized that okay, this is gonna be super cool that I wrote something and that too recursive, and this is gonna solve a very major problem because a lot of people were struggling around the fact that how to get that error code. So this was the second instance when I actually encountered algorithms. So when I was working as a student developer for Google Summer of Code, at that time I was working with Meteor.js, right? Meteor.js is a framework that writes both front end and back end in one framework only. So at that time I was expected to do some DOM manipulation. During that DOM manipulation, like my mentor at GSoC asked me to see that the ways that I'm using for this DOM manipulation are the most efficient or not. At that point of time, I read a lot of documentations and realized the fact that, like, if you guys already don't know, the browser renders the HTML in the form of a document object model tree. So it's a whole tree object that renders in the whole DOM. Now, at one point of time, actually one operation that I was using from Meteor.js API was actually deleting a node from the DOM and then adding a node to the DOM. And that's not the most efficient way, because deleting a node from the tree, as you guys know, can be a very expensive task. So at that point of time, instead of going with an API that was deleting a node, we went for an API that was just updating the values of the node and then doing some lazy, I would say, rendering to later render the new updated data. So this was like, Meteor.js is kind of like an old framework now. Not a lot of people use Meteor.js, but yeah, at that point of time, like going through the documentations and realizing the fact that okay, how to interact with the DOM tree of HTML was something very, very important for me. So this was another instance when I actually encountered algorithms for my day-to-day work. Apart from my own work, a lot of fellow friends of mine also work in companies like Flipkart, Amazon, Microsoft, etc. So one of my friend who was working at Flipkart was involved in a lot of retail work, like when you buy a product, that product from the vendor goes in a truck to the Flipkart warehouse, then from the Flipkart warehouse it is traveled to another warehouse, so on and so, like there is a whole life cycle that a product goes through. Now how they manage this life cycle, this whole life cycle model is managed inside Flipkart using graph algorithms, right? So they maintain a whole graph, they maintain a lot of nodes, and from one node how exactly the next process is going to be hit, that is going to be exactly monitored and maintained inside a graph. They used a complete graph based implementation to actually manage this whole retail process. This was one implementation. Apart from that, if you are going to work with a lot of machine learning algorithms, then in machine learning algorithms also concepts like dynamic programming is used. In machine learning algorithms, concepts like trees are like very aggressively used. Obviously, apart from the mathematical logical implementations, these are some extra data structure and algorithmic knowledge that you need to have for at least machine learning purpose. Even from the front end, as I already explained, the whole DOM tree is actually a tree data structure. How to interact with the tree, when the tree is going to be rendered, right? Concepts like virtual DOM is also going to be there, which is going to be having some basic, I would say, knowledge that will require some basic knowledge around data structures and algorithms. So on and on, in my opinion, if you ask, then data structures and algorithmic knowledge are not going to be used for like 90 to 95% of the task. But for the remaining 5% of the task as a software engineer in your initial career, like 2 to 3 years, whenever there will be an, I would say, requirement when you have to write an algorithmic code, then you need to be top notch at it, right? You cannot make a lot of mistake, because that task is definitely going to be very serious. That is going to be very delicate. A lot of things are going to be dependent on that. But to be very honest, for your day-to-day work, having good knowledge of software engineering, like writing good code, making good classes, writing good low-level diagrams, right, making understanding high-level design, understanding low-level design, these things are going to be more important. Understanding SQL, understanding your operating system, understanding network, like how HTTP work, how HTTPS works, what is the TLS layer, how can you make I would say a persistent HTTP connection, what are sockets. These kind of knowledge are going to be more, I would say, useful for your day-to-day task in software engineering. But actually, to be very honest, in order to understand these things also, you need to have knowledge of data structures and algorithm. That's why these are the foundation of computer science. For actual day-to-day work, you may be learning new frameworks, new languages, etc. So my opinion says that if you are someone who is already into your career for initial 1 to 2 years, then also don't stop solving questions around data structure and algorithm, because even if you are going to take a shift, if you give some interviews, you are going to take a shift, then also a lot of data structures and algorithmic code are going to be asked to you. And as I said, for your day-to-day tasks as well, you are going to be using data structures and algorithms sometimes, and a lot of times like I have faced the fact that the traditional dev flow is already there, and whenever you have to make changes, then you have to write cleaner code. Data structures knowledge is going to be more used rather than the algorithmic knowledge, and so on and so forth. So like all of the things that I have discussed is completely based on my opinions and my experiences, and what like my few fellow mates have experienced during their work. So that was it for today's video, guys. If you have encountered some algorithmic implementation during your software development engineering work, then don't forget to comment down your experiences in the comment section below. I'll be reading all of them in this video, right? And if you like the video, then don't forget to hit the like button, and we are going to meet very soon with all of you guys in the next video. Till then, take care, guys. Bye bye. Have a great week ahead, and love you all.